Welcome to Brain Vision.
Well, we have the stone's mass. Let's write down ms for the stone's mass. Well, stone's mass is equal to 3.00 kilogram. The block's mass, right, is mp, right? So block's mass is equal to mp, that is 15.0 kilogram. And the constant force of the spring is K, that's spring constant, which is equal to 500 Newton per meter. Well, taking right is positive direction and the left is the negative direction. Well, this direction is positive and this direction is taken is negative, right? We have initial velocity of stone is equal to 8.00 meter per second, and initial velocity of block VB1 is equal to 0 meter per second. This is not MP, rather this is B, that's mass of block, right? And then final velocity of stone is equal to minus 2.00 meter per second, and VB2, right, is equal to unknown, right? We need to find out this value. Well, we know that in collision of all kinds, since there is no external net force on the system, the total momentum before the collision equals the total momentum after the collision. So P1 is equal to P2. Well, if the collision is between two particles A and B, then we have PA1, right? That's initial momentum of particle A plus initial momentum of particle B is equal to final momentum of particle A plus final momentum of particle B. And we know that momentum P is given by mass times velocity, right? Okay, and now the momentum equation can be written as, since momentum equals mass times velocity, therefore we can write ma times va1 plus mb times vb1, that is equal to ma times va2 plus mb times vb2, right? Now let's do calculations. Well, for the collision, since the block is on a frictionless surface and there is no external net force, so the momentum is conserved during the collision. Let us plug in values in equation number 1. Let's call this equation number 1. Then we have 3.00 times 8.00 plus 15.0 times 0 is equal to 3 multiplied by minus 2 plus 15 times VB2, and solving for VB2 is equal to 2 meter per second, right? Well, this is the velocity of the block right after the collision. Now we calculate the kinetic energy of the block right after the collision. Well, kinetic energy of the block is equal to 1 divided by 2 times mass of block times VB2 square. Well, let's plug in numbers. 1 divided by 2 times mass of block, well, that's 15 times 2 whole square, and that is equal to 30 joules, right? And from the conservation of energy after the collision, this kinetic energy is converted into elastic potential energy stored in the spring. Well, compressing the spring a distance x from its original position, so we have elastic potential energy is equal to kinetic energy of the block. Well, that is equal to 30 joules, and well, elastic potential energy is half k times x squared, and half k, well, k is 500 times x squared is equal to 30, and solving for x equals 34.6 centimeter.